Hello, welcome back. So today let us discuss oxymercuration and demercuration reaction. So this is a very important property of alkene, and in the previous video we have seen halohydrogenation, right? So where we added HX to an alkene. So we saw two different rules, Markovnikov rule and anti-Markovnikov rule. So Markovnikov rule happens like when what is Markovnikov rule? The nucleophile attacks where there is less hydrogens, or the hydrogen attacks where there are more hydrogens. What is anti-Markovnikov rule? Just opposite. The hydrogen attacks where there is less number of hydrogens in the carbon atom of the alkene. Right. So anti-Markovnikov addition takes place in presence of um, peroxide. Okay. Now, so today let us see oxymercuration and demercuration. So what is the significance of oxymercuration demercuration reaction, or I'm going to simply call it OMDM. So what is the significance of OMDM is the product formed in OMDM is 100% Markovnikov product. Why? Let us see what is OMDM. And we will discuss another reaction in the next video. It is called HBO, not the TV channel, of course. So in HBO, you will get a 100% anti-Markovnikov product. So let us see first OMDM, or oxymercuration demercuration. What does the name suggest? Oxymercuration, something related with oxygen and mercury. Demercuration means something removal of mercury, right? So you take an alkene, add some mercury thing, and then a mercury compound is formed. That is oxymercuration. Very simple. That's what we'll see here. So you take alkene, okay, and then add mercuric acetate. What is mercuric acetate? CH3COO twice Hg. Means it looks something like this. Hg. Oh, C C CH3 double bond O, like this. Or I can just call it OAC. Similarly, OAC. It looks like this. Mercuric acetate, and you add water in presence of THF. What is THF? Tetrahydrofuran. Okay, tetrahydrofuran. Then what does in oxymercuration what happens is a hydroxy alkyl mercury compound, means an alkyl group which has something OH hydroxy and some mercury compound like this. Some mercury compound is there. Okay, this is oxymercuration. Let's see an example. So we take CH3CH double bond CH2, and then we use mercuric acetate H2O and THF. Once we use this, what is formed? So a Markovnikov product where the OH is attached where there is less number of hydrogens. Right? Means the hydrogen is attached where there is more hydrogen. Okay. And then that is formed. OH is formed here, and then HgOCOCH3 means a mercuric acetates part is here. It got attached here, and acetic acid is formed out. How? Let's see the mechanism first of oxymercuration. So, step one, this is the alkene, right? So, this alkene is first attacked with mercuric acetate. Now, when mercuric acetate is attacked, has attacked the alkene, so what would happen? A complex is formed where this double bond gets open like this, and then it forms a double bond between Hg and CH2, and then this gets a positive charge, right? So there is a attraction between these two, or in some books they directly show a bond too. Okay, so we represent like this. So when we are taking electrons, the delta positive charge is formed here, and Hg anyhow it is going to get a positive charge, right? Because it is like forced to give one bond, right? And simultaneously an OAC is left. That's what we are seeing here. The OH from H2O comes and attacks this delta plus, this slight positive charge. So as you can clearly see, a Markovnikov product is forming here. The OH is attacked where there is less number of hydrogen, right? So this complex is called cyclic mercurium complex or cyclic mercurium ion. This is highly stable. Okay. And then OH hence attacks on the open ring. So this will be the product formed. Okay. So this is oxymercuration. This is one part of the OMDM. What is the second part? This mercury compound, whatever is formed, we are going to react with NaBH4 and H2O or NaOH. Okay, H2O or NaOH. So this mercury compound with NaBH4 and OH minus, some reaction takes place, and this reaction is not studied really carefully till now. Like the correct mechanism is not yet known. It is assumed to be a free radical mechanism, but we don't know. So NaBH4, which is sodium borohydride, and OH minus, they both react with this mercury compound, and this acetate, this mercuric acetate ion, which is extra, is removed. So at the end, what we want is removal of this extra ion. So an alcohol is formed. So this part is called demercuration, means removal of some mercury compound. Hence alcohol is formed. At the end of OMDM, the moral of the story is an alcohol is formed. Example you can see here. We have this after the oxymercuration reaction. We are using this reagent, and then what is happening? This is replaced with a hydrogen. Simple. So, and what are the byproducts you can see here? Like GNABOH4 and something. Okay. Let's see the mechanism of demercuration. Okay. So, in demercuration, there is no mechanism to discuss because it's not really discussed till now. This is removed and just put the hydrogen. Okay. That's it. Very simple. And in this reaction, product is 100% Markovnikov product. Simple. In 5 minutes, we have completed the whole OMDM. Now, let's solve just 3 questions on OMDM. Okay. So, a very important thing, as we have discussed the mechanism, you can clearly see no rearrangement of carbocation takes place. In other cases of hydro, sorry, halohydrogenation, if carbocation is forming, you can rearrange it. But here, carbocation itself is not forming. A delta plus is forming. It's not carbocation. Okay. So here, no rearrangement of carbocation. That's a very important learning from OMDM, and it can make trick questions because uh, by mistake you can, like, solving questions, we can directly rearrange the carbocation by thinking something, so don't do that. Now here we can see HgOAc twice, mercuric acetate and water, and THF is not though mentioned, but then also we can understand. So what happens, a Markovnikov product is found, means where there are more hydrogens, the hydrogen attacks here. You can clearly see there are two hydrogens here, one hydrogen here. So one hydrogen will be here. Okay. Hydrogen has occupied this place and the other place will be occupied by OH. Simply do that. So just place a OH here. Okay. Now there is another thing called alkoxymercuration. Means here instead of H2O we are using ROH. Means here OR goes and attacks. Okay. The OR goes and attacks the site. So an ether is formed like this. Okay. This is called alkoxymercuration. And let us see a quite interesting example. The oxymercuration of one butane. This is an alkyne. Okay. So what would happen? This double bond will form a complex like this, and then OH is formed here, and another OH is formed here like this. So this is highly unstable. So again, you treat it with H2O. In OMDM, anyhow, H2O is removed, right? Dehydration takes place. So a H2O comes out, and then, sorry, I'm really sorry, a keto group is formed. This is an important example, the OMDM of 1 butane. That's it. This is OMDM, and in the next video, let us see HBO, that is hydroboration followed by oxidation. Right. Thank you and have a nice day.